3D services are also included in the scope of the Saracen project. 3D is the ability of a display device to create the illusion of depth of either still or moving images. When watching a 3D scene, one has an impression of the third dimension, of depth, meaning that what we see is perceived as a replica of real objects or environment. The market for 3D devices is growing rapidly. According to DisplaySearch.com, 200,000 3D TV units were sold in 2009. It is estimated that 64 million units will be sold in 2018. But it's not only TV sets that are hitting the market. 3D mobile phones, tablets and laptops are increasingly popular. This growth of availability of devices is accompanied by content. More and more 3D movies are available on Blu-ray and on the internet, especially YouTube. Additionally, the consumer market offer is extended with 3D camera equipment available for personal use. Human ability to see in 3D is caused by the fact that each of our eyes sees a view of the same scene but from different perspectives. Our pupillary distance, which is the distance between the centre of the pupils in our eyes, is typically between 55 and 65 millimeters. Therefore, in order to create an illusion of depth, a different image must be presented for each eye. This means that we need at least two images. The technique using two images to create 3D illusion is called stereoscopy. Put simply, the part of the brain responsible for vision, the visual cortex, receives two different images and combines them to create the 3D image that we see. This principle is used in 3D displays. Modern 3D displays aim to deliver separate images to each eye. This is called channel separation. There are numerous methods for displaying 3D images. This tutorial focuses only on those available in the consumer market. The most basic 3D display method is anaglyph. Separation of channels is achieved by using glasses with color filters. A single image is displayed in each different view, and a color filter is applied which matches anaglyph glasses, which the user must wear. Anaglyph images can be printed or displayed on traditional TV sets and monitors. Unfortunately, the colours in the glasses impede the perception of colour, causing the image to look unnatural. In polarization technology, the display shows two separate views. A polarization filter on the screen causes the views to be polarized in orthogonal directions. Polarized glasses filter the light in such a way that each eye receives a different view. Polarized glasses are passive and so do not require charging. Due to the lack of any electronic components, they are cheaper and lighter than shutter glasses. Unfortunately, the 3D image quality is not usually as good as that offered by shutter technology, especially if we consider multiple viewers. Currently, the most popular method of 3D display is shutter technology. Here, the display is refreshed at twice the normal rate and displays left and right frames alternately. Is synchronized with the display and covers one eye at a time. Glasses are usually made of liquid crystal. The display refresh rate and flickering frequency of the glasses, typically 120 Hz for the display and 60 Hz for one eye of the glasses, is high enough not to be noticed. It's quality of 3D experience, but requires the user to use active glasses, which are usually quite heavy and need time to recharge. They are also expensive when compared to other types of 3D glasses. Currently, autostereoscopic displays are mostly used in devices with low geometrical dimensions, such as mobile phones or tablets. This technology requires no glasses at all. The screen is covered with a layer that allows each eye to see different pixels on the screen. This is achieved with either a parallax barrier or lenticular lenses. Although this technology does not require any glasses, it does require the user to observe the screen from a set of predefined positions, which can be uncomfortable in some situations. "3D technology is progressing rapidly. The best technology of today may be rendered obsolete by tomorrow's hardware. Saracen allows the playback of 3D content on the most popular platforms. We would like our player to be technologically independent and as flexible as possible. Currently in the Saracen system, 3D video is transmitted in 2 independent streams, one for each view. This concept will simplify possible future development of the Saracen system, such as multi-view mode. This mode will be dedicated to auto-stereoscopic displays and provide more views depending on display capabilities. Each stream of 3D video is coded in SVC, meaning that depending on network capabilities, a higher video quality will be presented. Additionally, scenarios exploiting binocular suppression effect were included. In a nutshell, research on the human visual system proves that the quality of video perceived by a user is only slightly lower when asymmetry, in terms of quality, exists between delivered views.